Hi there, this is for University of St. Thomas, Math 005, and this is Lesson 7. We're going over sections 7.3 and 7.4. In order to do that, though, there's some information that you need in order to be successful. First of all, I want to talk about the equations of the line, and there's three forms that we use a lot. There's what's called the standard form, which is what you'll normally see in an academic book. If you'll see it in a math book when they're talking in terms of formally writing it out. You'll also see point-slope form, and you'll also see slope-intercept form. We're going to talk about each of those three, and then we're going to talk about some other things as well. Standard form has ax plus by equals c. And just so that you know, Cengage requires that the ax has to be positive when it's written out. Otherwise, it tells you it's wrong. And even though mathematically they are exactly the same thing, when you have them the other way around, Cengage will tell you that it's wrong, even though the ax could, in fact, be negative. All right, so a and b and c are constants. That means they are a single number that does not change in the course of the equation. They cannot all be zero. That should be pretty obvious. If they're all zero, while 0x and 0y equals 0 is a true statement, it's not particularly helpful. All right, so moving along to point-slope form, this is a case where you have either figured out the slope or you know the slope and you have a point available, right? The known point that falls on the line. The way we write this up is y minus y sub 1 equals m, which is our slope, times the quantity of x minus x sub 1. Now, m is our slope, which we're going to get to how to figure that out in a minute, and our x1, y1, or x sub 1, y sub 1, that's an actual point on the line. The x and the y, those are variables. They're generic. You're not going to put you're not putting in two actual points, okay? You're putting in one point and then we're solving for the other variables. All right, and then we have the slope-intercept form. We have y equals m, which is our slope, x, which is our variable, our input variable, and then plus b. B is a constant. It is our y-intercept. All right. When we go through the process of doing this stuff, hopefully it will make more sense, but I want to at least give you the overview of this before we go on to do any of the actual arithmetic. Slope. Slope can be called a number of different things. It could be called rise over run. It could be delta x or delta y over delta x. It can be rate of change. Slope, obviously, we refer to it as m. There's a number of other ones out there. I'm not going to spend all the time talking about that, but you should be aware that there's more than just the name slope. Slope has to do with how quickly something is changing going up and down compared to how quickly it's changing left and right. So we have x1 and y1 is a single point, and x2, y2 is another point. And I want to point out here that my y's are in the numerator. And I also want to point out that this x1 has to go with the y1. I don't get to mix and match my numbers. Okay, so the pair has to stay together. The y's are going to be in the numerator, the x's are in the denominator, and the pairs have to stay together. You're going to subtract them to find out what our slope would be. And should wind up being either just a straight up number, like an integer, or it could wind up being a fraction. Okay, obviously if it's a fraction, it can be converted into a decimal as well. All right, so hopefully that is helpful, at least superficially, to understand what slope is. It's how quickly a line is going uphill or downhill, depending on whether the slope is positive or negative. Now, given our Pythagorean theorem, I know almost everybody knows about the Pythagorean theorem, you know, that whole a squared plus b squared equals c squared. What a lot of people don't get is what that actually says. All right, so a and b are both going to be lengths of sides for a right triangle. All right. And when I say that, I'm talking about something that does this, right? Here's my right angle. Here is going to be either my A or my B, and this is going to be the other one. And in a second here, I think I said, yeah, I'm going to have my A be, my A is the X values, the difference of the X values, and my B is going to be the difference of the Y values. Now, does it genuinely matter which one is A and which one is B? No, not really. But I did this just for the purpose of, giving ourselves something very clear to work with. And then this is going to be our C, which is the hypotenuse. And that's the side that's opposite of our right angle. All right. So in order to get our distance formula, we're going to use our Pythagorean theorem. All right. We have our understanding that a squared plus b squared is going to equal c squared, right? We're going to trust that that's true. Now we're going to say, let the distance squared equal our c squared. Okay. And I'm going to, just because we're talking distance now rather than this generic c squared, you can leave it as a c squared. There's nothing that says you can't do that. But from my perspective, it's easier to keep track of it when I have the letter making more sense to me. So I'm going to use a d squared for distance. Okay, my distance squared. So now I'm going to say my A, which is the side, right? I'm going to find out what the distance is on that side of the x's, right? So this right here, right? This piece here becomes my A, because I'm looking at, here's my x for one of those points and here's the other, right? So this is my x2 and my y, or my x1, right? Because I'm doing my subtraction. This is the furthest one away. Here's my closer one to the 0 or to more negative. So then I'm going to go ahead and I'm going to have my x2, and then here's my x1. Okay, again, we can work around that. It doesn't have to be one or the other, but just for convenience sake and hopefully so people can see what's happening, I'm going to spell this out this way. All right, so then my B is also going to be the same kind of deal, except that here I'm talking, right, how high this is. So that's going to be my y2 minus my y1. All right, and we can kind of play with this a little bit. We could say that this is actually the point we're working from, but we take our height, right? That's as high as our y goes, right? Normally this would be our other point, but so if you were to take a look at it, this would be our x2, y2. But in order to kind of get the visual of this, I want to make sure that people can see what's happening here. All right. So now I've got my side B, which I've said is running along the length of the triangle that's on the y-axis. My A is the x-axis side. And so now we're going to say, we're going to plug it in. All right, now I'm going to go back to, here's my distance formula, right? Here's my, I said instead of having a c squared, I'm going to have a d squared. And then I said my A is going to be this thing, this x squared minus, or x sub 2 minus x sub 1. That's this right here. And then my, I'm squaring that because that's my A squared. My B squared, same kind of deal. I'm going to have my y's, and then I'm squaring that. Now I want to get, instead of having it be d squared, I want to get it to d. I want just the distance. So I'm going to take the square root of all of this mess all at one time. Okay? Now, hopefully that makes some sense. If it doesn't, feel free to go back and review the video. Hopefully it will make more sense as well as I go through the process of going ahead and working through some of the problems. All right? I'm going to leave off this video at this point.